Yeah, very good evening, everyone. Welcome to the series of M.Tech, the Great Amrita Alumni Conclave. Students are all optimistic about their future. Once that student has achieved a great height, we are proud of him or her to enlighten us about his or her knowledge. Well, today we have the topic, an overview of data science. We have Anjali Muralidharan, who will explain about the topic. She's working with TCS as a system engineer. She's the Amrita Alumni who has pursued M.Tech in data science from Amrita Vishwa Vidyapeetham. So before getting into the session, if any of the participants have any queries, please type it in the chat box. So Anjali, I welcome you to the session. Therefore, we can start the series. Over to you right now.
Thank you, Sachin, for this lovely introduction. So yeah, I'll just share my screen and we'll move towards the session. So hope my screen is visible to you all. I hope, Sachin, my screen is visible.
Yes, it's visible.
Sachin, my screen is visible, right?
Yes, it's visible. You can, we have PPT. Yeah. Make it full screen.
Yeah, the PPT is visible. Okay.
Fine.
So, hey folks, this is Anjali, and like Sachin said, I work as a systems engineer in Tata Consultancy Services, Bangalore. So here I am presenting to you an overview of data science, why the real world use cases of data science, and why I chose Amrita for data science. So I'm an alumni. I studied from the year 2019 to 2021. So what is a generic overview of data science? See, most of the cases, why do people need, like so much of data is present across the globe, so much of raw data is there. Those kind of data needs to be processed to give some meaningful insights. So that is the knowledge where data science came into picture. So what is basically this is like a generic thing, the generic terminology, which I would say about data science. So data science, we have, this is a generic overview. See, what we have is basically, but we need to have a knowledge about the computer science part. Then we need to have a knowledge on the data science, data analytics part, which involves the math and statistics. And then we have machine learning. Then business or domain expertise is basically you need to be good at your communication skills, and so in that cases you can basically understand the business side and get further insights from their end. So that is basically why we need a business or domain expertise when it comes to data science. Suppose if you're working with an organization, you can actually simplify their work in the better manner if you have a knowledge on data science. So this, and the best part about learning data science is, though I come from a CS background, but I know many of my friends from non-CS background can also do data science. That is a wonderful advantage. It's not like a normal DevOps role or anything that you need. If you come from a CS background, you'll be able to study it. If you come from any possible background, even I've seen friends of mine who have done into doctor or MBBS, even those kind of domain peoples learn tools like R and Python and all, so that they can apply it in certain genetical modeling in those kind of activities. So this is basically like our generic overview. Now let's move on to the detailed overview of data science. So detailed overview of data science is first and foremost important thing is math and statistics. Why math and statistics are equally important is because I'll be telling it to you in the previous lectures, because to understand this involves like a lot of algorithms and a lot of calculations. So in order to understand the background work of those algorithms, you need to have a good understanding of your math and your statistics. Statistics is basically, it helps in telling you certain probability or where this particular part of your decision making skill comes into picture if you have a good knowledge on statistics. Team player skills and ethical skills is what I told you earlier. Like suppose if you're a business user or something, in order to understand the overview of the organization, like in what perspective can you help them out? Suppose they're doing a task. Like for example, let's take YouTube. The recommendation system of YouTube is basically using data science. Suppose how many ever times you clear out your history or you remove out all the videos you have seen, somewhere or the other you find them there. You find them somewhere or the other, you'll find related videos to that. Similarly, in Facebook, all your friend recommendations or all those kind of systems use data science. Suppose you would have just crossed a particular lane or something, or you would have visited a particular place. And then later on Facebook, you will find a person you may know. So haven't you been surprised, like, how do I know this person? I just met him right there. How does Facebook know? So here the Facebook uses the recommendation system. Then communication skills is exactly like, suppose if you work as a business analyst. So in that kind of scenarios, you need to get the use cases from the customer end or the client side. And in order to understand their use cases, you need to impart it to the development team so that they can understand the concept and implement those things in terms of coding. Next comes the machine learning skills. Machine learning skills, like I said, are those algorithms which you use to implement your model. Data visualization skills is, suppose most of the data, right, if you just put them in algorithms or those kind of perspectives, it doesn't work out. So if you put them in a pictorial view, it makes them easier to understand, like in terms of a graph or in terms of a pie chart or a flow chart. If you put them in that way, people find it more easier to understand. Like you're able to draw insights from data when you put them on a graph. So data wrangling and pre-processing are like the initial stages where, see, whatever data you get in the market is like basically it's raw data, or you don't get always structured data out in the market, like you get them in proper CSV files or anything. So you get them in the form of raw data. So this raw data needs to be pre-processed. They'll have missing values, negative values, values that are not even there, certain columns of data that you don't even need for your final outcome. So this is like the most important step of data science. The initial part of doing anything is, more importantly, you need to have data wrangling and your pre-processing skills are there. That's the most of the data analysts and the data scientists across the globe, what they basically work on is cleaning out the data. Coding skills. Coding skills basically involve, you need to have a good hands-on on Python and R programming language. So this is like a roadmap, which I would say, which I followed in my journey towards being a data scientist. So first one is very importantly, your data analysis skills, and then it involves your mathematical skills. Then programming language. Programming language, you have multiple, we have just 3 or 4 programming languages. But if you have a good knowledge, which is pretty much simpler to learn when compared to the other languages used by developers. IDE is an integrated development environment, a machine learning, then you have web scraping, data visualization, and deployment tools, which we use for data science. So this is just a generic overview, which I'm presenting it to you. So in detail, we'll go in the further slides. So data analysis. So like I mentioned, data analysis is the key important step, because whatever data you get from the market, it's always filled with junk, unwanted information and everything. So in that kind of a scenario, what you need is basically, these are the key important steps that we use. So one thing is that if you're on your journey of becoming a data scientist, first most important thing is EDA. EDA is nothing but exploratory data analysis. Exploratory data analysis. Suppose if you get into an organization, more than knowing all the algorithms and everything else, initially what they do is, they basically check out on your EDA or your exploratory data analysis skills. So if you're this is like the starting stage. If these skills are particularly strong, it will definitely help you in order to become any kind of data. If you receive that kind of data, you will be able to finish it out. Then we just apply, we do a decision making on the algorithm, we put it into a visualization. These are like the initial stage. So what happens in exploratory data analysis is a lot of statistics and everything involved. So first we collect the data, and then we gain a knowledge of what kind of the data it is. And then what we do is that we confirm on the data types and what probabilities, like in which situation, what kind of data can be taken. Then we apply certain statistical techniques like measure of dispersion, where we calculate variance, standard deviation, and range based on the data that we have acquired. Then what we do is skewness or right and left. kurtosis, thinner peak, wider peak, all those things. If you delve deep into the statistical concepts of data science, like of statistics, you'll have an understanding more on that. See, these are the measure of central tendency and measure of dispersion are basically the key important concepts when you look at it in terms of statistics. Third is nothing but the graphical representation. Graphical representation is usually done in terms of we use a histogram, a box plot, a bar plot, or a dot plot. So like when we move into the programming languages part, like Python and all those programming languages, they have a built-in libraries for all these kind of tools. So feature engineering. Feature engineering is suppose you have cleaned all your data. You've taken your data, you've cleaned, you've removed all the missing values, you've dropped all the null values that are not a part of your data. And what you do is you do feature selection or a feature engineering. So after data processing, the next step what we do is feature engineering or feature selection. So in that kind of a scenario, what is to be done is you select important features of your data. Suppose most commonly used example is, suppose let's say we want to buy a house price prediction or a stock market, like say a stock house price prediction. Suppose I want to say, so what I'll see for these factors like the locality, the year of construction, then basically that how, where it is, or do you think all these factors matters like the number of floors in the house? Those things are not much into detail. So those kind of things comes into picture when you do your feature selection. So let's say when you're taking a house price, for example, like how, if I want to tell you that for a particular thing, which house price you want to take. So in that kind of a thing, we basically take like normal features like the house, the locality, and its year of construction. You transform it. Then you do a feature creation. We do encoding and decoding. So here one example is, see, deep learning is a part of AI where a feature extraction can be automated. Data wrangling, see, the most important difference between data cleaning and data wrangling is, data cleaning is basically like we are just removing the null values and we are just imputing null values or something, or we are dropping null values which are not required. But whereas when it comes to data wrangling, what we are doing is that we are removing out the missing data and we are parsing it or converting into a raw data form. So usually most of the data, when you're a beginner into data science, you take it in the form of CSV files. You have to convert them into form of CSV files or XLXS files. So in those kind of scenarios where you're converting a raw data into another format, or you're parsing it into a particular format, is called as data wrangling. So you have missing data, date and time or HTML parsing is being done, cleaning, structuring out the data, string processing or text processing. Next is, as I mentioned, mathematical skills, which are very important when it comes, is one is statistics, one is differential calculus and linear algebra. So statistics, amongst this, statistics is considered more important is because when you use concepts when it comes to machine learning, that point of time when you take the understanding the background of a particular algorithm, like for example, like let's say simplest algorithm I would take is a decision tree algorithm. Like, will this particular bank approve loan for a particular person? So what all they see? They see if your age factor, they see your income, they see whether your marital status, all. So these are the factors which comes to decision tree algorithms. So in order to understand that particular background, like how this is happening, why is this algorithm doing this? So that kind of scenarios we use statistics. And in order for the previous lecture, in order to do exploratory data analysis better, in those kind of scenarios also statistics is very important. Then we have linear algebra, and differential calculus is like when you delve deeper into the statistical concepts, we come across concepts like linear algebra and differential calculus, like when you do matrix multiplication and everything. This is like programming languages. So the most most commonly used programming languages when it comes to data science is one is Python and one is R programming. Python programming is most commonly used because one thing, it's easier to learn when compared to other normal developers programming languages like C, C++, and Java. So why Python programming is because Python programming, when it comes to data science, it has all the inbuilt libraries. Like suppose for cleaning, for scientific computing, we have a library called as NumPy. For pandas is basically used to read a CSV file. Then in terms of visualization, everything, like suppose, see, whenever we take a data set, right, we have to split it into two halves. A training data set where we train our data and testing data set, and then we do our final computation. So for all these parts, we have an inbuilt library when it comes to Python. So when it comes to our programming languages, we use it mainly when we are doing statistical computing. Java. But the advantage is that Python and R programming languages, they're all open sourced and they're freely available. SAS is also considered as a very good programming language when it comes to data science. But the only issue is that, it's like a licensed software and it's not used much when compared to Python and R. Java. So when you come across concepts like big data, it has large chunks of data and you need to do programmings on big data kind of thing. That time we use the concept of Java. So ID, the most, as per in the market, many particular IDs are used. But in order to make your computing a little more easier and to make it a little more understandable, we have these particular IDs which are being chosen and used by data scientists and recommended by them across the globe. So one is PyCharm. PyCharm is the first one I would say is PyCharm. PyCharm is like a very good, it consumes, but compared to Jupyter Notebook, Spider Notebook, and Google Colab. So these are the 4 IDs that are used. But PyCharm is, some people tell that when compared to Jupyter and Spider and Google Colab, it consumes a lot of space. So, but yes, it's a desktop-based ID, and you can use it, install it, and use it. It's a good ID comparatively, but I would say Jupyter and Spider also. Jupyter is basically used because if you're a beginner to data science or if you're a beginner to Python programming and if you want to practice, but when you see it across organizations, Jupyter is not used much. But then comes is most commonly used is Spider. So these two, Spider and Jupyter, usually come under one particular prompt called as an Anaconda prompt. So these two are readily available there. So what happens is, finally, what happens is when you use a Jupyter or a Spider programming language or any of these, we have Visual Studio, we have Sublime Editor, we have all these possible editors. So when you use this possible, these two programming languages, what mostly happens is these particular things, suppose if you want to do a, let's say a concept on deep learning. So you need to have a laptop which has, let's say, it should have its NVIDIA graphics card inbuilt. It needs to have its graphics card inbuilt. All those things should be inbuilt in a particular thing. So in that kind of scenarios, what happens is, or you need to have a Core 5 processor or those kind of things should be there. So in that kind of things, everybody cannot go and buy let's say an NVIDIA graphics card inbuilt laptop or anything. So in order to overcome all those things, because in order to run all these things, you need all these things in your system. If you are using Jupyter or Spider. So in order to overcome all these things, like if you want to use concepts of TensorFlow and all that, you need something like Google Colab. So Google came up with this ID called as Google Colab, where it's like an online ID where you can share all your code with other people. And it's a much better ID because you don't need all these things are inbuilt within the ID. Like for example, like you don't need a graphics card. All the GPU processing, graphic processing unit is present within the ID. Then machine learning, when it comes to the concept of machine learning, you have process like classification, regression, dimensionality reduction, clustering, and deep learning. So classification is like, machine learning, we have 3 categories we need. One is supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is basically like when your data is labeled. Suppose, let me say, if I put a box and a name, okay, this is like, suppose, let's say I'm doing a flower classification or an animal classification. So flower, I would name it rose and a lily. So when I say rose and lily, the system will know, and then it will give me a classification based on this. It will separate it by itself. But when it comes to unsupervised learning, you have usually unstructured data. Unstructured data, and those unstructured data, in order to pre-process it, the values are not labeled. Last concept is basically it's reinforcement learning. Reinforcement learning, a quick example is basically if you have had those phones where you played those snake games, where you have to actually move. It's basically used in the concept of gaming. So when, like, for example, when you have seen those old phones where you've had a maze, you will have a snake moving. And then if you hit on the right point, the snake, otherwise, if you go eat a bomb, the snake eats a bomb, then you get a penalty. So that is basically the concept of reinforcement learning. That is where you have an agent and then you have an environment of that particular agent. So each time the agent moves in an environment and it attains like a positive, suppose if the snake swallows, like, let's say a ball or something, then it gets what? You get a reward. If it goes and swallows a bomb, you get a penalty. So this is basically the concept of reinforcement learning. So classification, we have so many kinds. We have binary classification where we classify it into two categories, or we have multi-class classification. Then you have regression. Clustering is basically used in concepts where, you know what, you have multiple sets of data and you want to group them. So those kind of concepts we use clustering. Deep learning is mostly comes in the concept of AI, where you have like models like TensorFlow and those things. So those kind of concepts we use deep learning. Then web scraping. Let's say you see something on the website and you want that particular data from the website. So Python has these particular URLs. So usually it's present in Python, like Beautiful Scope, Scrapey, URL lib in Python. These are three particular libraries which helps you to scrape the data. The most important thing is data visualization. So for data visualization, we have multiple tools. So Matplotlib is, like I said, it's a library that is present in Python. Apart from that, mostly we use Tableau and Power BI for visualization purposes, or ggplot. Deployment tools. So when you have to deploy your code somewhere, so mostly when it comes to development, we use tools like Jenkins in order to deploy our thing. So when it comes to data science, the most commonly used is you have AWS. So AWS has multiple tools for data science like SageMaker, and then you have Microsoft Azure Cloud. So use cases of data science, like I mentioned, one is in the healthcare. Like if I would take my final year project, was basically based on analysis of a major depressive disorder using an ensemble technique. So that is one most interesting cases where you take the symptoms of different particular patients and you detect what kind of a depression they are into, whether they are into clinical depression, whether the depression is based on drug abuse or those things. So that is one place where data science plays a major role in terms of healthcare. Image recognition, like let's say face recognition or anything. So like most of the apps now there where they detect the age of a person by just clicking on your face. Fraud and risk detection, then online delivery, internet searches, speech recognition, like Google Audio, you have seen, right? They're able to recognize your sound, and prediction is one place. YouTube, Facebook is like the same examples which I mentioned it before. In retail is one of the most commonly used cases for data science, where it shows you like, you know, you visited this place. Why don't you try visiting out this place also? Especially when it comes to Zomato also, it shows you recommendations like, you know, this particular cases or anything. Most commonly used is Netflix. Suppose you've watched a movie and then it shows you like movies based on the same genre. Spotify app is one of the most commonly used tools which uses data science, because where you select a particular genre of music and then it gives you recommendations based on your likes. Fraud detection, utilizing social media, same case in YouTube for predicting and then for giving you videos based on your interest. So healthcare, it's like I mentioned earlier, genetics, genomics, drug discovery, then predictive analysis. Suppose if you put in data, like, you know, if you put in data of a person, it can, so one use case is where it detects whether the person is under a major depressive disorder scenario, or if he ends up with a diabetes. All those things can be predicted easily in terms of data science by seeing the person's thing. Suppose, let's say, fraud detection also is one example case where you see that a person has given a wrong currency note. So like that, in a real life, day to day, like with or without your knowledge, you're coming across data science use cases. So this is like why I chose Amrita for data sciences. So I was going across multiple colleges because I wanted to take this up as a degree of mine, because I was really excited after my B.Tech final year project, which I did it on data science. So I was choosing it to make it a specialization in terms of my M.Tech. And then at that particular time when I was seeing through, we had in my place, we just had 4 colleges which offered this at that point of time as a specialization in terms of an M.Tech degree. And then when I realized that is that when Amrita actually offers a better data science program when I joined the college, because now if you would have seen my GitHub profile a year back before joining Amrita, maybe I would have had 5 to 6 projects. But being in college, every semester we had projects on every subject, like six projects, including the ones which you're asked to do extra. So like that, my GitHub portfolio improvised, and I had a projects of around 20 plus, which has increased tremendously across the year. Then when it comes to the brand name, what I received when it comes to my workplace is that, so while I was doing my master's is where I got my offer letter. So what I realized is that a friend of mine or a colleague of mine who had already finished her master's with this brand name of Amrita in our organization, she happened to get into a better project when compared to me. So that is one reason. So a brand name which the college offers, and the faculties were indeed very supportive. So when it came, because I had to do the course and my work at one point together. So in that point of time, and the amount of a good hands-on experience. See, moreover for data science, no matter where you go, universities or other people offer it for the 6 months duration, but moreover the hands-on understanding and the theoretical experience, and moreover the real-world use cases the college portrayed has helped me a lot. So that's all, guys. That's all, folks. Thank you very much.
Anjali, that was a nice of a session, and I'm not getting about any questions from the participants side. Not getting any relevant questions. They are asking only about admissions. So that was a beautiful session. Thank you, Anjali. Thank you so much.
Thank you, Sachin, for giving me this opportunity.
Thank you.